Hello students, this is lesson 7-3, estimating the population mean. In this lesson, we're going to learn to estimate the population mean and find margin of error using a population mean. Another thing we're going to learn in this lesson is how to use a t-table, or better yet, a t-distribution critical values table. We've mastered how to use a z-score table, and now, today, we'll learn how to use a t-distribution table. Here's our first question. This is an example that says, a common claim is that garlic lowers cholesterol levels. In the test of effectiveness of garlic, 49 subjects were treated with doses of raw garlic, and their cholesterol levels were measured before and after treatment. The changes in their levels of LDL cholesterol in milligrams have a common mean of 0.4 and a standard deviation of 21.0. Use the sample statistics of n being 49, x bar, or the mean, being 0.4, and s, our sample standard deviation of 21, to construct a 95% confidence interval estimate of the mean net change in LDL cholesterol after being treated with garlic. After you finish constructing that confidence interval, decide what does the confidence interval suggest about the effectiveness of garlic in reducing LDL cholesterol. This is enough information to plug into StatDisk and let StatDisk find your confidence interval. We'll do that next. But first, I need to teach you more about the symbols and the values you need to construct it by hand. So let's do that now. The requirements for the beginning is that the data be normally distributed or have a sample size greater than 30. This is our margin error formula when sigma, or our standard deviation, is not known. The margin error is t sub a divided by 2, or alpha divided by 2, times the standard deviation of the sample divided by the square root of n, where t alpha divided by 2 has an n minus 1 degree of freedom. And we have a table I'm going to give you that explains how to find that critical t value, or the critical value of t of alpha divided by 2. The t in a t distribution basically means tail, as in this is a tail, and these are tails. This is a one-tail t distribution, or one-tail test with a 5% or 95% confidence interval. And this is the 5% of A. A is 0.05. And this is a two-tail test, where A is divided by 2 is 0.05. So I got half and half here. This is a two-tail test. We only use a one-tail test when the portion of the data we don't want is really minuscule, very tiny. It doesn't really affect anything. Only time we use a one-tail test. The vast majority of the time, we're going to use a two-tail test. So most of the answers we're going to work with are a two-tail test. If you ever actually calculate t, it's essentially the mean of the sample, take away the mean of the population, divided by the standard deviation of the sample, divided by the square root of n. We generally don't calculate t though. And our last definition is degree of freedom. The number of the degree of freedom, or collection of sample data, is the number of sample values that can vary after certain restrictions have been imposed on all the data. The degree of freedom is often abbreviated DF, degree of freedom, and is calculated by n, the sample size, take away 1. On the t-table, you have a section here called the degree of freedom, and this is where all the numbers are. If the number that we have for our degree of freedom doesn't fall on one of these numbers, we round upwards to its closest value, or we round downwards to its closest value. Our only new symbol is t sub alpha divided by 2. Again, this is the critical t value separating the area of a divided by 2 in the right tail of the distribution. This is the area that we don't want within a two-tail distribution. This is how we're going to find our confidence interval. It's going to be the population mean. It's going to be in between our sample mean, take away the margin of error, and our sample mean plus its margin of error. Our margin of error is a critical t value of A divided by 2 times the standard deviation divided by square root of n, and the degree of freedom is a total number, take away 1. You're going to refer to the table, what you're going to have, each problem. Now we're ready to begin the problem to deal with the cholesterol level in garlic. In the problem, our total number of participants was 49. Our standard deviation was 21.0. The mean was 0.4. And we had a 95% confidence, which implies the area is 0.05. Area divided by 2 is 0.025. Our confidence interval should be the population mean should be between the sample mean, take away a margin of error, and the sample mean plus that margin of error. To continue, we need our margin of error formula. And to find t sub alpha divided by 2, we need to understand that this critical value changes as the sample size changes. If n equals to 49, our degree of freedom is 49 take away 1. Since 49 take away 1 is 48, our degree of freedom is 48. So we need to go to our t-distribution table to decide what t of alpha divided by 2 equals with that degree of freedom. So here's our t-distribution table. And basically alpha divided by 2 being 48 is, this is 40, and there's 45, this is 50. 48 is not on the list, so the closest we can go is 50. So we use 50. And I want a 95% confidence interval. So for a 95% confidence interval, basically what we want is our A of 2 tails be 0.05. So we're looking here. That lines up right here. So it's 2.009. This is the value of t sub a divided by 2, our critical value. So in order to find that margin of error, it's going to be 2.009 times our standard deviation, which was 21.0, divided by the square root of n, our total number. N was 49. If you evaluate that using your calculator, you should find that the margin of error is equal to about 6.027. So now we construct our confidence interval because we know x bar and we know our margin of error. So our confidence interval should be mu in between x bar, which was 0.4, take away 6.027, and 0.4 plus 6.027. So that means our population mean should be between negative 5.6 and 6.4. This represents LDL cholesterol. So basically our answer is we're 95% confident that the limits of negative 5.6 and 6.4 actually do contain the value of the true mean, population mean, the mean of the changes of LDL cholesterol for that population. Because the confidence interval contains a value of 0, it's very possible that the mean of the changes of LDL cholesterol is equal to 0, suggesting that garlic treatment did not affect the LDL cholesterol levels. It does not appear that garlic treatment is effective in lowering LDL cholesterol. The last thing I want to mention is finding sample size using the population mean. Basically, all of our variables remain the same. We have a new formula though. In this case, n is going to be our z-score at a divided by 2 times the population standard deviation divided by the margin of error squared. That should give us the minimum number of participants we need to have in the survey in order to be able to make predictions for 95% confidence or 90% confidence or create a confidence interval. Let's do an example with this one. Assume that we want to estimate the mean IQ score for the population of statistics students. How many statistics students must be randomly selected for an IQ test if we want 95% confidence that the sample mean is within 3 IQ points of the population mean? So in this case, to have a 95% confidence interval, A is 0.05. Our z-score for 95% confidence interval is 1.96. Our margin of error is within 3 points, so 3. And our standard deviation, they didn't mention it, so it's basically going to be this. It was decided on some previous lesson that the range of IQ scores for statistics students was 60. So basically our standard deviation would be that range divided by 4. So it'd be 60 divided by 4, or 15. All right, so basically we want to need to know how many students we need to actually complete this. It should be our z-score of 8 divided by 2 times our standard deviation divided by the margin of error squared. With a 95% confidence interval, that z-score should be 1.96. That margin of error, that standard deviation was 15. That margin of error was 3. That number should be squared. So that's true. N should be about 96.04. We always round that up, so it's about 97 people. So we need a sample size of 97 people or to conduct that survey. That's all I have. Good luck.